Welcome back to Miss Eddie's Math Movies, where it's a cute to be a square. Today's lesson is 7.2, Similar Polygons. By the end of the lesson, you will be able to identify similar polygons. First, we should establish what similar polygons are. Similar polygons are two polygons that have congruent corresponding angles and proportional corresponding side lengths. All right, so I think we should compare this to being congruent. And the symbol for similar is just a squiggle. So I'm going to make a little chart for us out here. And we're going to have congruent on one side and similar on the other. So congruent and similar. What's the difference between being congruent and similar? Well, first of all, the symbol, this is the congruent symbol. This is the similar symbol. All right, so there's one difference. Then in congruent, your angles are congruent. Well, same thing here with similar. Your angles are congruent. But here, your sides are congruent as well. Here, your sides are proportional. We're going to talk about what that means. All right, and congruent, the scale factor for being congruent is 1. So we call the scale factor K. K equals 1 here. Here, K is anything but 1. I guess it could be considered 1. So what is the scale factor that I'm talking about? It is the ratio of two corresponding side lengths. I'll give you an example. So similar figures look alike, but they're a different size. They're the same shape, but a different size. All right? So let me give you an example. Kind of get this in your head. Here's two triangles, and they say they're similar. Remember, that's the symbol for similar. List all the pairs of congruent angles. Well, we know that they have congruent angles. So let's see here. P must be congruent to S. R must be congruent to T. And Q must be congruent to U. So we did that. Now we need to write the ratios of the corresponding sides in a statement of proportionality. What in the world does that mean? Well, since the sides are proportional, we can write proportions. So we could put ST over PR, all right, or we could put SU, so here's SU. SU would go over PO, or TU would go over RQ. These are the proportions that we could write. Now it wants us to check to make sure all these are equal. Because look, we said they're equal. Here's our equal signs, but we need to check. So let's do ST over PR. ST is 8. PR is 10. Well, what is 10 over 8, or 8 over 10? We could divide both of these by 2, and that's 4 to 5. Okay, let's see if we can get that again. Now let's do TU over RQ. TU is 16. RQ is 20. I could divide both of these by 4. And what do you know? I get 4 to 5. Then let's try the last one. SU to PO. Oh, P, that must be a Q. PQ. All right, SU is 12. PQ is 15. 3 goes into both of these. And it ends up as 4/5. So that's what it means to be similar. All the ratios are equal to 4/5. So our scale factor is 4/5. So look how we checked. We saw the angles were equal, and we saw that the sides were proportional. And that proportion, that ratio is 4 to 5. That's what K is. That's our scale factor. So here in example 2, we have to decide, are the polygons similar? All right, so we need to check to see if the angles are equal. That's our first step. So G is equal to M. Yeah, there's two marks there. H is equal to K. There's a single mark. And J is equal to L because there is a triple mark. So all the angles are congruent. So there's our first check. Now we need to check to see if the side lengths are proportional. So we have to check each ratio, short to short, medium to medium, and long to long, and make sure they make the same thing. All right, so MK, that's 12. We're going to put 12, well, what side goes with 12? 9 does. 12 over 9. All right, let's divide both of those by 3. That is 4/3. 4 to 3. Okay, so that's one we've checked. We have to check 2 more. KL, we're going to check 16 over 12. Those go together. They're corresponding. We're going to divide everything by 4. We get 4 to 3. Hey, we're doing okay. We've got 4 to 3, 4 to 3. We just have one more to check. LM 20. 20 goes with 15. Divide both of these by 5. What do you know? 4 to 3. So the corresponding side lengths are proportional. So the angles are equal. The sides are proportional. That means the triangles are similar. So here's our similarity statement right here. Similarity statement. GHJ. So let's make sure GHJ goes with MKL. And the scale factor is the ratio of the sides. That ratio that we got every single time was 4/3. Notice it's B to A. B is on top, A is on bottom. That's what we did. If they wanted A to B, then the answer would be 3/4. So just make sure you look at what they want. All right, determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. All right, this is just like example 2. So first you're going to check the angles. Are the angles congruent? Then you have to check, are the sides proportional? So go ahead and start checking. 9/6. All right, check all of those. And then if they are, you're going to write a similarity statement. And give a scale factor if it's a yes. So go ahead and do this now. Look at the example from 2 if you need to. RST is similar to GHJ. Find the value of x. So that means that the angles are equal and the sides are proportional. If the sides are proportional, we can write a proportion. So let's go ahead and do that. Let's see, x is to 9, right? X and 9 go together. X is to 9 as, there's a bunch of things we could do here. We could do 8 to 12 or 10 to 15. It doesn't really matter. I'm just going to do 8 to 12. X is to 9 as 8 is to 12. Okay? So make sure if you start with the smaller, smaller always goes on top and bigger goes on bottom. And we solve this, right, by cross multiplying. 12x equals 72. X equals 6. There we go. Example 4. Find the ratio of the length of the patio to the length of the pool. So we're doing length to length. Well, the pool is obviously inside the patio. Here's the pool. So the length of the patio is 48. The length of the pool is 32. Well, what goes into both of these? I think 16 goes into both of those. Divide this by 16, divide this by 16, and you get 3 to 2. So the ratio is 3 to 2. Now it says find the ratio of the perimeter. Oh, okay, well, if we're going to do that, we need to actually find the perimeter. So all the way around the patio is 48 plus 24 plus 48 plus 24. Which 48 plus 24 plus 48 plus 24, 144. Then around the pool, 32 plus 16 plus 32 plus 16, right? There's the pool. That's 96. So now we can find the ratio. So we're going to do 144 for 96. I believe 12 goes into both of those. 12 goes into that 12 times. 12 goes into that 8 times. Oh, we can keep going. 4 goes into both of those. 3 times and 2 times. Oh, wow. So the sides made 3 to 2, and the perimeters also make 3 to 2. So if you look at the next question says, what do you notice about both the ratios? They're the same. And that's what this theorem says right here. The polygons are similar. The ratio of the perimeters is equal to the ratio of the side lengths. So you can add them all up, or you can keep them separate. DE over AB, EF over BC, or DF over AC. All right, you're going to do these now. This is like example 3, and then you're going to find the perimeter of triangle STU. Put that over the perimeter of triangle PQR. So kind of like example 4. Go ahead and do these now. For example 2, you're going to write a proportion and solve. This is M cubed signing out.